To find the acceleration of an object, you need to find the net force on the object and the direction of that force, and then divide that magnitude by the mass, and that'll be the acceleration. If there's only one force acting on it, this is pretty simple because you don't really have to add anything, just divide by the mass, because force equals mass times acceleration. But if there are multiple forces in different directions, you sometimes need to break them apart into components to find the overall acceleration. So let's take this problem for example. A skier is traveling down a slope that is inclined 30 degrees above the horizontal. The coefficient of friction between the skier and the slope is 0.1. Which of the following best describes the acceleration of the skier? So to solve this problem, let's draw a free body diagram of the skier on this slope. So we have a slope angled 30 degrees. And our skier. So the forces acting on him will be gravity, the normal force, and friction. So gravity is straight downwards. The normal force is perpendicular to the slope, and friction is going the opposite direction of the way he's traveling, and he's traveling down the slope. So this is what our free body diagram looks like. I think some of the lengths of the arrows are incorrect, but we can just discount that for now. So the easiest way to do this is to break this into components. And it's probably best to make our X and Y axes something like this, because the normal force and gravity kind of cancel out in that particular y-axis, so the only acceleration we have left after that is in the x-axis, and it makes things really simple. So now we can redraw this with the components we need of gravity to make it all in one axis. So this is what it's gonna be. And the way I figured out that angle is because it's 30 degrees. So we can take that original gravity and break it into components of the axes I selected, and use the trigonometric like sine and cosine to find the separate components by making it into kind of a right triangle. So about the force of friction. Friction has a direct relationship with the normal force. So we know that friction is equal to the coefficient of friction times the normal force. And in this case, the coefficient of friction is 0.1. So we know that friction is 0.1 n, just like that. And we also know what n is equal to because it's equal to the component of gravity, which is perpendicular to his slope that he's skiing on. So that's going to be equal to 0.1 mg cosine of theta, which we figured out earlier that was that component. So now we have all the acceleration, or all the forces we need in both directions. The normal force and part of gravity just cancel out on the y-axis, so that doesn't really matter for us. We're just worrying about the x-axis. So they're in opposite directions, so we're going to be subtracting one from the other to find his acceleration. So it's going to be equal to, so the net force, let's do that first, is equal to mg sine 30, because that's what our theta is, and then we're going to subtract 0.1 mg cosine 30, just like that. And then from there we can take acceleration by dividing this whole thing by the mass, because force equals mass times acceleration. So acceleration is equal to g sine 30 minus 0.1 g cosine 30. So that's the answer, but I don't have a calculator on me, so I'm gonna pause this video to do that and then come back when I calculate it. Okay, so I finished my calculation, subbing 10 in for gravity as instructed by the AP test, and I got 4.13 meters per second squared. And this is pretty close to answer B on the AP test, which is 4 meters per second squared. So it's safe to say that that is the answer.